डॉक्टर बाबासाहेब आंबेडकर ओपन यूनिवर्सिटी.
Namaskar friends, welcome to the course on cybersecurity tools, techniques and countermeasures. So today we are going to discuss the remaining point of cybersecurity essentials. Friends, in earlier session we discussed learning objectives, what is cybersecurity, Indian cyberspace and cybersecurity concepts. Now in this particular session we will be discussing basic cryptography, public key infrastructure, and we will summarize this session. So let's begin the journey again. Now what exactly the cryptography is? The word cryptography is derived from the Greek and its literal translations is hidden writing. In the old times it mostly used to send secret messages in a way that the intended recipient can only be able to read it. Cryptography is a very critical important part of the security applications, products and applications in terms of using different cryptographic algorithms. Understanding how cryptography works, it is important to understand to make sure that the data which is transferred between sender and receiver is safe. In around 1900 BC, Egyptians began to use pictographic to convey the secret message, and this was known to be a cipher. Cryptography can be strong or weak. Its strength is measured in time and resources it would require to recover the plain text. How does cryptography work? A cryptographic algorithm is a mathematical function which is used in encryption and decryption process. While cryptography is a science of securing data, cryptanalysis is the science of analyzing and breaking secure communication without knowledge of the key. Combining both cryptography plus cryptanalysis, it is called cryptology. The most common to none is the classical cipher, is the substitution cipher. The most common to none is the classical cipher, is the substitution cipher, which works by substituting each letter in the alphabet with one another when writing the secret message. The key here is the number of character which is used for substitution, and below is one of the such example. Let us say we have written A to Z, ABCD to XYZ. Now it has been converted with another text, so that has been spelled like NOPQRST and something related to it. Now how exactly it has been converted, so that we will discuss over here. So where A is equals to N, B is equals to O, C is equals to P, so that is something related to N, O, P, Q, R and so on. So the text begin with A has been replaced with the text begin with somewhere from N, O, P and so on. So using this cipher, the message hello world would be written as the text mentioned over here. It is simple substitution cipher known as Caesar cipher. So where you can say that A has been replaced with N, B has been replaced with O and C has been replaced with P. Now let us talk about symmetric encryption. Now what exactly symmetric encryption is? So it is also known as conventional encryption, which has been introduced in the late 1970s. So this technique is used to provide confidentiality for the data transmission or to store data using symmetric encryption method. So there are two well-known symmetric encryption algorithms used. They are data encryption standards, that is called DES, and the another one is advanced encryption standard, that is AES. So both algorithms are block cipher encryption algorithms. So here is a symmetric encryption model. So wherein plain text is being inputted. So secret key shared by the sender and recipient, so that is K. So wherein we have applied encryption algorithm, for example DES. Now the transmitted ciphertext, that is the equation has been given over here, and the secret key shared by the sender and recipient, so that will be again they will be receiving the things, and the decryption algorithm, that is reverse of the encryption algorithm. So whatever algorithm we have applied at the time of converting it into ciphertext, now the reverse algorithm will be applied over here, okay, and again whatever message has been conveyed by the sender, the same will be received by the recipient. So let us understand each component which is shown in the above symmetric encryption model. The plain text, the original message or data provided as input into the algorithm. Encryption algorithm, encryption algorithm used which performs operations on the plain text. Secret key, secret key is also an input provided to the encryption algorithm. The text number of substitution or transformation performed by algorithm depending on the key. Ciphertext, encrypted message which is produced as output, which depends on plain text and key used. For the same message, if there are different keys used, ciphertext will be different for both the key used. Decryption algorithm, it is the same encryption algorithm which runs in the reverse manner, which takes the ciphertext and secret key as the input and generates the original plain text. So this is how exactly symmetric encryption works. So there are two requirements for the symmetric encryption algorithm to work. The first one is strong encryption algorithm, none to both party, sender and receiver, and the second one is secret key should be none only to the sender and receiver only. So Caesar cipher is a very form of symmetric encryption, and symmetric cryptography doesn't address following issues. The attackers can eavesdrop the shared key between sender and receiver and can steal the key and decrypt the data. So this is one of the most important issue that has been addressed in the later algorithm, and this is where the concept of public key encryption or asymmetric key cryptography comes in the picture. Now what about asymmetric encryption? Asymmetric encryption is also known as public key cryptography. It uses two mathematically related but unique keys, a public key and a private key. Each key has its own unique function. The public key is used to encrypt the data and the private key is used to decrypt the data. It is computationally infeasible to obtain the private key from the public key. It's primarily used for the authentication, non-repudiation and key exchange. Anyone with the public key can encrypt the data but cannot decrypt the same. Only the appropriate receiver with the private key can decrypt the data. Even if the attacker knows that the sender is transmitting the data to the receiver, also data passes through multiple channels, there is nothing he or she can do, as the data can only be decrypted by the private key. So this is a model, a figure for this particular example. So here we have plain text, we have public key, and the algorithm has been applied for the encryption. So it will be converted into ciphertext. Again, that will be decrypted by the private key, and the receiver will receive a plain text. All communications which takes part between sender and receiver includes the public key. The private key is never shared, they are simply stored on the software or on the machine used. Some of the example of the public key crypto system are Algamal, named after its inventor Tahar Algamal. Now let's talk about RSA, which is most widely used even in current time. Now let's talk about hash functions. Cryptographic hash functions are a mathematical algorithm that take input of the arbitrary size of data and generates the fixed length hash value or message digest or simply digest, and they are also designed to be one-way functions. So here you can see we have various inputs. Okay, now the cryptographic hash functions have been applied and the digest have been communicated. So yeah, here we have some sort of examples related to hash functions. This means they are not reversible in nature. Let us discuss hash functions. There are few properties of the hash function which are mentioned below, due to which they are still widely used in a different information security applications. It is deterministic, which means it will always give the same hash value for the same input message. Computing hash value of the message is faster. It is infeasible to generate the same message from hash value. Even a very small change in the message will change the hash value completely. It is infeasible to find two different messages with the same hash value. Due to such properties, they are widely used for digital signatures, message authentication code, indexing data in the hash table, fingerprinting, finding duplicate data, checksum to identify any modifications in the data. Let's talk about hash algorithms. So there are various hash algorithms available, but the most widely used hash algorithms are message digest algorithm, that we can call is MD algorithm, a byte oriented algorithm that produce a 128-bit hash value from an arbitrary length message. There are various versions of these algorithms present, such as MD2 RFC 1319, MD4 RFC 1320, MD5 RFC 1321. MD5 is the third message digest algorithm after MD3 and MD4, which process data in 512-bit blocks, which is broke down into 16 words compressed of 32 bits each. The output from MD5 is 128-bit message digest value. So secure hash algorithm, it is a cryptographic hash function published by the National Institute of Standards and Technology (NIST) as a US federal information processing standard, which takes an input and produce a 160-bit hash value known as a message digest, typically rendered as a hexadecimal number which is 40 digits long. It works by transmitting the data using a hex function, an algorithm that consists of bitwise operations, modular additions and compression functions. There are a series of algorithms exist, such as SHA1, SHA2, SHA3, etc. Apart from this, there are another well-known hash functions exist which are used, such as RIPEMD, Whirlpool, etc. Now friends, let's talk about digital certificate. So there are several issues which exist with the public key crypto systems. One of them is man in the middle attack, in which one of the potential threat, that is, in this particular attack someone tries to fake the key with user ID and name and tried to pretend the same person, which is not, and resulting in this the data is encrypted with the attacker's key. It is vital to know that public key to which you are encrypting the data is the actual key of the intended recipient and not a forged one. To overcome this, digital certificates have been introduced, which will ensure that whether a public key truly belongs to the actual owner or not, it acts much like a physical certificate. Now, the digital certificates consist of three things. One is a public key, second one certificate information, that means identity information about the user, and the third one is one or more digital signatures, and that has been a unique for all the users. Now, what exactly public key infrastructure? Let's talk about public key infrastructure. A public key infrastructure PKI is a combination of policies, role and procedures which are needed to create, manage, distribute, use, store and revoke digital certificates and manage public key encryptions. It includes components such as certificate authority CA and the registration authority, that means RA. Now, the certificate authority creates a certificate and digitally signs them using its own private key. As it is the central component of the PKI system, using public key of the certificate authority, one can verify the authenticity of the digital certificate and can check the integrity of the content of the certificate. Registration authority refers to the people, which can include group, company, process and tools which will help users to enroll them with PKI systems. It also checks public key belongs to its owner or not. On the other hand, CA is the software which issues the actual certificates. Friends, let's summarize this session. This unit has provided details regarding basic cybersecurity details and current cybersecurity postures of the nation. Moving forward, we have also seen the basic security fundamentals and building blocks of the cybersecurity, which are confidentiality, integrity and availability, and why they are important. Also, how they can be achieved using different encryption models and its understanding using pictorial representation. So friends, this is all about cybersecurity essentials for the course cybersecurity tools, techniques and countermeasures. Friends, we'll meet again in the next session for unit number 2 for the same course. Till then, goodbye. Thank you.